Hey, how's it going? This is Turkish Coffee. I'm back with a blue team video, specifically on Splunk, which I must admit I found very interesting. I have to tell you that Splunk is not my mainly my main SIEM. Yeah. In my day-to-day job, I just work with Sentinel-1 and Sentinel. So I'm not super duper familiar with Splunk, but you know, while I was preparing for a TCM certification, I came across this amazing SIEM, and this video is basically to show how I can handle basic queries, basic Splunk stuff, and you know, it's basically a write-up for people interested in BOTSv1. Yeah. So as you probably know, Splunk itself gives the possibility to learn and the SIEM. You're doing a lot of challenges, as you can see here, you know, and this is very interesting because, for example, Sentinel and Sentinel-1, they don't give users and future users, future SOC analysts this chance. Yeah. So kudos to Splunk, which basically they gamified this whole experience. Yeah, this learning experience. Very cool. And basically they give you all these challenges, and also they give you for free a fully functional, fully working Splunk instance. You know, there is a data set which is related to the challenge you, or the game, or the CTF, not sure you want to call it, that you want to take on. Yeah. And then you can do the queries and all the things. Yeah. So very cool. You know, I wish Azure and Sentinel-1 did the same thing, but at least to the best of my knowledge, there is nothing like this in those two platforms. Pity. But anyway, today we're working with Splunk, and yeah. So let's just begin. So this is the challenge. Yeah, BOTSv1 version 1. It's kind of an old one. It's 11 years old, but you know, the queries and the reasoning behind is basically the same. Yeah. So here you can read the whole brief, but you know, I think you are here mostly for the write-up. Yeah, you really know what this thing is about. Yeah. So what is likely, this is the first question. Yeah, what is likely IPv4 address of someone from Poison Ivy group scanning really not Batman.com for web application vulnerabilities? Yeah. So here we have three pieces of information. We're talking about an IPv4. We already have a domain here, and then we have also the hacking team name, yeah, most likely, and a web application vulnerability. So let's not just go straight to, oh, you know, I have to find. Let's just reason, yeah. So this is the same thing. This is the same setting for me in while I do CTF. Let's not just go straight to the thing. Oh, I have to find the IPv4. Let's just reason. Let's just piece together all the things. Yeah. So anyway, here we go to Splunk, and we have to build up a query. Yeah. So and the query for this thing is basically this one. Yeah, so let me just explain to you. So every time you have to work with Splunk, the very first thing you have to do is telling Splunk which data set you are like interrogating or investigating. Yeah, so for example, if we do this, hopefully it works, you know, all the events, logs and stuff matching actually within this data set are, you know, shown. You know, and there is a lot of stuff. And as you know, as a SOC analyst, you don't have a lot of time. Yeah, so then we have to, you know, tune the query itself. Yeah, so how do you tune it? Understanding what you're looking for and what you have available. Yeah, so in this very case, to get not only the IP of the attacker, but also other information, which I'm going to show you just in a second, you have to add this thing. You know, let me explain what this thing is. Yeah, so this is the data set we are interrogating, we are investigating. I'm not sure if I can say interrogate in English, but in my language, it's interrogating. Anyway, then we have a source type stream HTTP. So basically, we tell him with this filter here, we telling Splunk only give us logs which are HTTP related. Yeah, so for example, I don't know, web requests, web responses, like URLs, domains, user agents type, and all those things. Yeah, okay, which is basically very much related to the IPv4 we're looking for. Okay, so now we have to go down here, and you see there's a filter which says source IP. Of course, then we also have the destination IP, where a lot of stuff. If we click on here, you see we have a lot of traffic from these IP. Okay, so which is, you know, it stands out a lot. If you click on it, Splunk is adding in the query this thing here. So let's just scroll down. Very simple stuff, you know, we don't have to reinvent the wheel and things like that. Yeah, no. So let's just go down, and we have a lot of information. Okay, so we're basically doing some sort of OSINT investigation. This is not probably OSINT investigation, but you know what I want to say is that we have a lot of information just in plain sight with just this filter here, you know, with this query. Okay, so the very first one, and I'll leave it to you, is this. Okay, so what might be this thing here? To me sounds like, guess what, maybe some sort of an injection. Next again, we have, let me just Joomla. You know, Joomla is a content management type of thing. Yeah. Next up, let me show you Chrome. Now this one again, Joomla. We have here. Oh yeah, and Acunetics. You know, Acunetics again. You know, so we already found 4 information. You know, we have a potential attack. You know, a potential attack here. You know, this really sounds like, to me, I'm not an expert on web application, but this is very, very similar to an injection attack. All right. Then we have some sort of a Joomla. application. So Joomla is a Joomla, not sure to spell it, is like a content management software. Okay, and where is it? Where did I find here, for example? And then we have Acunetics. What is Acunetics? Acunetics is like it's a vulnerability assessment type of thing. Yeah, so like Nasus, for instance, or maybe Nmap is not the same thing, but it's actually you can pretty much find vulnerabilities also with Nmap with some tags, But anyway, this so we already have a lot of information here. Yeah, we not only have most likely the public IP from which the attack started, or at least the scanning started, but we also have other information which we will utilize just in a few seconds. So IPv4, there we go. Okay, was right. Let me just all right, so up to the next question. So it says, what company created web vulnerability scanner used by Poison Ivy? Poison Ivy, right? Type the company name. We already know this, yeah? So it's Acunetics. You just have to look in the logs, look in the information, okay? And when you get something, just look around and you will find something else. I know this sounds like philosophical, but with just the IP we found, we also found some other information. Okay, and again here, what content management system is I'm really not Batman.com likely using Joomla. Yeah, we found it. Okay, so this is a bit more interesting. Yeah, just allow me 1 second. Okay, so what is the name of the file that defaces the I'm really not Batman.com website? Submit only the name of the file with extension. Okay, so let's do it. Okay, so this is the query, apologies. Let me explain. We already know from here. And so again, here is, let me just, okay. So what is the name of the file that defaces the marinobatman.com website? Submit only the name of the file with extension. All right. So we have to do like a step back here, yeah. So here was the query, that we used, yeah. And then we went to source IP. Okay. Where is it? Oh, my bad. We have to wait a second just before. Okay, source IP, it's this one, yeah. So most likely the attack was started from 4080.148.42. All right, good. If we then go into this other filter, we have most likely our, like, the victim, let's say the victim IP, which is this internal one, .70. Right? So let me just let me just add it to the filter here, and we have a lot of stuff. As before, we can see an attack here. This is an injection attack. There are many attacks, there are also some other information, like this is just a confirmation, Joomla again, Acunetics. This looks like another injection attack, SQL injection attack. Let me see if I can find something a bit different. I wanted to show you some other stuff. Allow me a second. Okay, again, SQL stuff. Yeah, a lot of SQL stuff. Here we go. So here we have what is this thing? This is a directory traversal attack. Yeah. So this is another attack we have detected, we have found, yeah, which was attempted, and this is very interesting. Yeah. So if you know a bit of web application attacks, you know that this is also very, very common. Okay. So basically, you try to pivot between directories and find something useful, something interesting. Yeah. And yeah, so this is it. This is another attack. I just wanted to show you. So in doing this, with this filter, just investigating a bit, we were able to find, just logically, we were able to find the attacker IP and our server IP, let's say the victim IP. Can we call it the victim or the target IP? Just poking around here and there. Okay, this is just logic, and this is a useful piece of information, especially when we go up to the next question. So what's the name of the file that defaced the amarillo@batman.com? Okay, so a file, it says a file. All right, so what we have to do, this is very simple. Let me show you the query. Yeah, okay, let's just give some seconds to Splunk. It's amazing, man, for real. Like, having the chance to practice and to learn Splunk in this gamified thing is amazing, for real. Like, it's amazing. I wish Sentinel and Sentinel-1 they did the same thing, but as far as I know, there's nothing like this. Anyway, so this is the internal IP of the victim, which we just found like a few seconds ago, and this thing, with this other filter, we telling Splunk, show me the HTTP GET requests. Okay, so what's the logic behind of this? Basically, the logic is, it says, what's the name of the file that defaced, our website? So the idea is there was a GET request, from our internal IP, and let's see if we can find something. Yeah, and probably that GET request, got the file we're looking for. All right, let's see. We already have something here. Yeah, so this is most likely the file. Was it the JPEG? Was it not a JPEG? Who knows? We also have domains. We also have domains. We have fully qualified domains and stuff. No, fully qualified domain. No, we have the domain too. which is and the port too. Okay, so if I'm not mistaken, this is like I'm not sure if it's technically a socket. Probably for a socket, it's an IP is needed. But anyway, we have also the domain and the port for which most likely this file was downloaded. Yeah. All right. So this is the name. Let's see. Oh my God, what happened? Okay. Next. Okay. All right. So it says this attack used DNS to resolve to the malicious IP. What fully qualified domain name is associated with this attack? Guess which one? Guess which one? Guess which one? This is it. And we have it in the same query. Yeah. Same query. Two different information. Yeah. Okay, good. Good. Next up. So okay, so here is the query, and we go with this thing. Yeah. So site. Okay. Site in this case is basically the website, yeah, and the port. We also fed Splunk with the website and the port, and then we telling Splunk to basically group results by the server IP, okay, the site, and the requested. Basically the requested URL path, So this is this is basically the query, and we have another IP here. Let's see if this is the right one. Okay, very good. Next is what IPv4 address is likely attempting a brute force against Batman.com. This is interesting. Yeah. So again, we have to do another type of a query, and let me explain to you. So up to here we know. Okay, so index, an index, a source type, we know this. HTTP method post, in this case is post. Why is post? Because it's posting stuff, it's sending stuff. Okay, so why not get? Of course, because posting is basically the attacker is sending data. In this case is sending guest password, so it's password, username, credential. Okay, destination IP, this is internal, this is our internal the victim. Form data. Okay, so form data, to my knowledge, this form data thing is basically anything like any login type of thing which is like sent over the victim. Okay, sometimes is like a login page form, or and something that you just tried, like those little windows, those little pages that you just type stuff on in, like credential, and then you just click enter or send, and then you try to authenticate or get into something. Yeah. So and then we say, listen, in that form data, in that login type of thing, I'm looking for something which has inside pass. As for pass is basically password, written in many ways. Okay, so we have a wildcard just before, okay, and a wildcard just after the password, pass WD, pass W, anything, you know. So we're filtering. We're looking in the events with like a login form, basically in this case, which has inside something closely related to pass as for password. Okay, so this is the idea, and then we group all the information by time. Okay, so we see, I guess this is the latest. Yeah, I guess it's the latest. The form data. Okay, so the form data, this is the what was passed through, and the source IP. Okay, so this is basically the idea. From time to time, I do also KQL in Azure Sentinel. Is similar, but in my opinion, Splunk is easier. At least in the in the approach. Okay, and not only in the how you find like information in the whole GUI, but also in the query. When building the query is a bit more simpler. Anyway. So table, okay, and here we have most likely what we were looking for. Oh, apologies, I had an issue with the mic. Anyway, what IP address is likely attempting a brute force password? Okay, so let's submit this, which is most likely the right one. Okay, but let's not just focus on the question. We are here to better ourselves, to improve ourselves, to improve the skills we have in SOC stuff. And in this very case in Splunk, this is not a capture the flag, you know, oh, I have the flag, I'm done. No, you know, let's try to understand what we are doing. Okay, so here we see the username. Most likely the attacker used the admin username, and then we also see a lot of passwords. You see passwords that they tried, you know, Rock, Co, Sammy, August, Phantom, Williams. This one, oh, this is very difficult to pronounce. Baby, Dave, and so on. Lifehack, I like this. So this is the idea, okay? So we also see what was tried, okay? We don't, again, guys, let's not just, you know, go through, oh, you know, I need the answer to complete the boss of the SOC thing, you know. It's just, okay, this is cool, that's cool, amazing, but let's also try to learn something to like understand how this thing is working. Yeah, so the source IP, we got it. Yeah, let's move on. What is the name of the executable uploaded by Poison Ivy? Okay, what is the name? And this is very interesting. Yeah, so let me show you. Mari isn't in here. Okay, so you use the query, and again we go with the data set, the known data set, and then we say and HTTP method equal post. Okay, so in this case we tell in Splunk to only show events where the HTTP method is post. Okay, why? Because it was uploaded, it was sent. Okay, so post, sent. You send stuff. If you post, you send. If you get, you get. Right? Okay, and then we have the group in here. Okay, so we have rare. This is like a feature, so it shows you just the outliers, results, and then you will limit by 20. You can also put 10, 50, 1 million, anything you want there, but it should be like related to this thing. Yeah, so you can't put like 1000 and then you have rare, because it doesn't make much sense, I guess. And then you go with the file name. Yeah. File name, this is the file name seen in the event. So look, This is if you play with Metasploit and all these things, this is like similar to some exploits and stuff. Let's see if it's that one. Okay, it's that one. Good. Up. What is the MD5 hash of the executable payload? Okay, so this is a bit more like interesting. Yeah, let me show you again. We go back here and we do this. I'm gonna explain you everything. I'm gonna explain you everything. So in this case, again, the data set, the name. Okay, the name, the file name we're looking for. This is probably an exploit or stuff. And then we have command line, and then we have the command line. So basically, this most likely this exploit was ran from like the CLI. Okay, in fact, if we just look somewhere here, this is the log, a raw log, I guess. And here it is, MD5, MD5 hash, and then if you put it here, you go, and I guess is the one. I guess, yeah, it's the one. All right. So up next we have GCPD reported that common TTPs for the Poison Ivy APT group, if initial compromise phase, is to send a spare phishing email with custom malware attached to their intended target. This malware is usually connected to Poison Ivy's initial attack infrastructure. Using research techniques, provide the SHA-255 hash of this malware. Okay, so my reasoning is the following. We just got the IP. I tried multiple things here, and I went like crazy in Splunk. So what I did was the following. You just go here, and you put the IP which we're looking for. Okay, so and then you go in like I think details, no details, relations. Yeah, so this is most likely what we're looking for. Okay, so here is the hash. This is the malware name. Okay, this was the malware name, Miranda Tate screensaver scr.exe. Okay, this is very malicious, very bad. As you can see, and then you just okay, and so this is the hash which we are looking for, I guess. So you go here and you slap it there. Okay, it should be the one. Okay, next up we have another tricky one. Which special X code is associated with the customized malware discussed in question 111? Okay, again, it's not a Splunk. Okay, so probably you can find it here somewhere. Community, somewhere here. Let me see. Somewhere in community, we have a lot of X code. Oh, this one. Adam was here. Yeah, this one, I guess. I would say that a couple of questions here are not very much related to, like to the. I don't want to say a SOC analyst job, but like 2 or 3 questions are kind of weird. Yeah, but like for example this one, I'm not sure to what extent is needed and useful for like a SOC analyst, but anyway, I showed you where to find it. Yeah, so where there was the hash, you just go in community and then someone posted it. Yeah, so anyway. Next up is, let's see if we have something more interesting. Okay, this is very interesting. What was the first brute force password used? Yeah. Okay. So this is very interesting, and this is something I come across multiple times in my job. This is the query, and I'm going to explain it to you. As from basically, you already know this. Yeah. So if you followed like the previous challenges, you already know this. Yeah. So this is the data set. This is what we are searching, what we are asking Splunk to show us or to look into. Okay, so this is everything web related, something which was posted. Okay, something which was posted, because what does it mean? It means that like the sender is sending, okay, credentials, so it's posting stuff, it's not getting. Okay, good. From data, again, this is the login form. Yeah, and in the login form we're looking for something which has some sort of like password. Okay, password written. Okay. Next, this is basically how the data. This is basically some sort of a regex or regex. Not sure to spell it. And then we tell in, sorted from the very first one, and then this is how the data here are shown. Okay, so we have the column of the time, the source IP, we have the password, listed like in a simple column here, and this is the from data. So this is the whole thing which passed through like the thing. Okay, so as you can see here, we have the answer most likely. So this was the very first password. As you can see here, this is a very, very simple let's say, apologies, I had another issue with my mic, but this is like a very, very simple word list. So first one is this, hopefully. Okay, good. Next is one of the password in the brute force stack is James Brodsky's favorite Coldplay song. We are looking for a 6-character word on this one, which this is another like weird question, that I don't actually know how much how much is this teaching us. Anyway, this is the query that I found useful, and this is it. So again, you already know everything here. Destination, we added something here, so this is probably the login page. Yeah. And then yellow it's song. Okay. And yeah, I know this sucks. This is not the best like question and way to, I don't know. I told you, like a few questions are not super interesting from a learning perspective, and I guess this one and the previous one are not super cool. But anyway, okay, yellow. Let's see. Who was the first correct password? Yeah, this is cool. The first correct password. This is cool instead. This is very cool, and if you are working like and if you are working as a SOC analyst, and like in a report, this can be kind of useful. Okay, so who was the correct password for admin access to the content management system running I'm running out Batman.com? Okay, so this is cool. Good. Here we go with the query. All right, so up till here, you know everything posted. This is most likely where the login page was. Okay, we have some regex, and then we have statistics, you know, how many times was used, and then you sort by count, you know. So here we go, Batman. Of course it was Batman, you know. What was the average password length used in the password brute force in attempt? Again, this is not super useful in a SOC setting, but again, we just practice, you know. Sometimes this is just a matter of, you know, practicing KQL, Splunk QL, and all those things, you know. Again, I don't think in a report I should put in a brute force or in an attack report, like to my boss or to the client, I should put this piece of information. But again, it's useful just to practice, just to get better as like at writing queries and stuff like that, you know. So this is it. If you find this question interesting, this challenge interesting, just go through it. To me, it's not super, you know. Anyway, this is the quest. This is the answer 6.19, 6.17. Let's see if this is the decimal. 6 closes whole integer. I don't know. Apologies. This okay. All right, I'm not very good at math. And it says how many seconds elapsed between the time the brute force password scan identified the correct password and the compromised login. Okay, so here is the query. This is like a complex one, yeah, like a complex one, and we have the result. So it's like 1 minute 32 seconds or so. Okay, so 92.17, I think 92.17, yeah. All right, 2 decimal places. As you know, I'm not very good at math. How many unique passwords were attempted in the brute force attack? You know, this is very interesting again, and it can be asked in the it can be asked like a client can ask you this, yeah. I'll show you. This is again more complex. So, you know, we started with 2 fields and then now we have a lot. Yeah. Deduplicate, stats. This is some sort of regex, not sure to spell it again. And it says 412 passwords, unique passwords, yeah. Yeah, let's see. Okay, this is it. So guys, this is it. This is the very first, let's say, time I'm using Splunk, and I must admit again, it was useful, very interesting, and even though most even though it's different, because this is like Splunk is different from my from the themes I'm working with daily, is it's interesting because I mean the dynamics, the mechanics behind incidents and attacks are the same. The difference is how you basically look for information. I mean, you look in the same way, but you have to tweak filters, and you have to learn how basically the sim is working. Okay, so this is it for today. I'm not sure I will go back to Splunk as for now, but maybe I'm doing also the ransomware attack here. Where is it? Where is it? Boss of the SOC. Maybe I'm not sure. I'm doing some other like labs lately, some networking stuff. Maybe I'm also doing this. I don't know. I have to think about that. But anyway, that's all for today. I'm very happy that I'm posting another video after roughly 1 year of inactivity on YouTube. But I had a lot of things going on, and so life gets in the way. And thank you very much for watching. Wish you a good day, and see you soon. Bye bye.